Welcome everyone to my new lecture where we are going to learn about Kirchoff's voltage law. Okay, so the sum of all EMSs in a closed electrical circuit is equal to the sum of all voltages on the resistors in that closed circuit. So all of these EMS that generators give you must be the same amount of the voltages of these resistors. So that's in electrical engineering very important, and that's the law. So we are now going to do. So this is the formula. When you do examples, tests, or whatever you have, this is sigma. That means the sum of all EMS. It can be a plus or a minus. I will show you when it's plus, when it's minus. Is equal to the sum of all the voltages on the resistors. Voltage on a resistor by Ohm's law, that's the resistance times the current that passes through that resistor is equal to the voltage of that resistor. And also it can be a plus and a minus sign. So let's do one example. You can write this electrical circuit down. Here you have E1. This is plus, and here you have minus R1, E2, you have here plus, minus R2, plus, minus R3, and the current is going in this direction. So we have to find the current. Okay, now what you can see that we have series. We have resistors that are connected in series. Why? Because all this one current is going to flow through all these conductors. So we can make an equivalent resistor Req that is equal to R1 plus R2 plus R3. So now I can remove this one, remove this one. Here I'll just put R equivalent. Now we have this electrical circuit. So how do we do? How do we work? How do we know? What's the word? How do we find? How do we do these problems? So, sorry, I have a bad English. First, you have to make a closed loop right here, like this, and you put the direction in which are we going to go and solve this problem. We can go in this direction, or we are going to do in this direction. Let's do the both. First, we are going to do in this direction, right, like this, clockwise. So, if the direction comes into in the minus sign of the EMF. On the battery, you put plus E1, plus E1. If it comes into the plus sign, you put a minus E2. And if it comes to the minus, you put a plus E3. Why? Because it's normal for a battery that its EMF looks from the minus to the plus sign. So if you come into the minus sign, you put a plus. If you come into the plus sign, you put a minus sign. Okay. So now, if the direction of the current is the same with the direction of this loop in circle where we are going to go, and we put a plus sign. So the current goes in this direction, this loop goes in this direction, and you will have plus I times R equivalent. Okay, so R1 plus R2 plus R3 is 3 plus 1, that's 4 plus 2, you have 6 ohms. Now, plus E1, that's 4 volts. I don't have to put now plus or minus. Minus E2, that's minus 2 volts. and plus 6 volts is equal to I times 6 ohms. I'm gonna, work here now. 4 minus 2 is 2, plus 6 you have 8 volts. Is equal to I times 6 ohms. You divide the whole equation with 6 ohms. Now, in the left you have 8 volts divided by 6 ohms. And here you just have I. And that's, let me just wait a second. That's, wait a second. You get 1 point, that I is equal to 1.33 amps. So this is the answer, but let's do let's do it in the other direction. So I'm now gonna remove all this here and this. So now we are going to go. We are going to pass the electrical circuit in the other direction. Now, let's see. It comes into the plus sign of E1, so we put minus E1. It's just that. Let me put on the light. So now we come. So it's minus E1 because it comes into the plus sign. That's not normal for the EMF to look from plus to the minus, so we put minus E1. Here it comes into the plus sign of E3, so that's minus E3. And here we go here and it comes into the minus, so we put plus E2. That's all the EMFs in this circuit. So now you see that, so now you can see what I is not in the same direction as this closed loop. So we put minus I times R equivalent. Okay, so now we have minus E1, that's minus 4 volts. Minus E3, that's 6 volts, minus 6 volts, plus E2, 2 volts. And now we have minus I times 6 ohms. Okay, so minus 4 minus 6 is minus 10, plus 2 that's minus 8 volts. With minus I times 6 ohms. We can divide the whole equation with minus 6 ohms. And now we have here minus 8 volts divided by minus 6 ohms. And here you will have just I. Why? Because minus 6 ohms divided by minus 6 ohms is 1. Minus and minus cancel each other out and it becomes plus. Here you have minus and minus. Minus divided by minus is plus. And you will have 1.33 amps. So it's the same result. You always have to get the same result. Even you go in this way or in this way. You just have to watch out on the signs. Okay, so thank you for watching. I hope you learned something today and see you in my next lecture.